All right, Unit 11, Day 3. Now we're going to build on what we did last time. So last time we found all of these things. We found zeros, y-intercepts, vertical asymptotes, and horizontal asymptotes. So we worked on finding those. Now we're going to put those things on graphs, okay? So what we're going to work with here is we're going to find those, put them on the graph, and then sometimes we may have to do the wave. Okay, so quick review of the wave rules. All we care about right now, positive leading coefficient tells us the right side's up, negative tells us the right side's down, and then we just care about single and double roots so we know whether we need to cross or bounce at each zero, okay? So remember, single roots, we cross through that zero. Double root, we bounce off, all right? And when we do the wave, we are going to use what are called the critical points. So the critical points are the zeros and the vertical asymptotes that we find, okay? Now, we're not always going to need to do the wave, okay? So one thing that we have to remember is when we do this stuff, our branches are going to be diagonal from each other, okay? So our branches will be diagonal from each other. Unless there is a double root. Okay? So they're going to be diagonal from each other unless there's a double root somewhere in this. So a zero, a vertical asymptote, whatever. If something's a double root, that's going to cause things to be a little bit different. They won't be diagonal from each other anymore, okay? They will never be vertical from each other because then it wouldn't be a function. So they'll never be on top of each other. They may be left and right, side by side, or they may be diagonal, but never right on top of each other, okay? So finding this stuff. It says find all of this and then graph. So what we're going to work with, right? Remember, zeros come from the top, equals 0. So if we look, we've got x equals 0. So there's that. Vertical asymptotes come from the bottom, right? So that's where the bottom equals 0. So add your 3, and we get that. Horizontal asymptote, we look at the degree. Okay, so here we have a degree of 1 and a degree of 1. So the degree of the top is 1, degree of the bottom is 1. So when the top equals the bottom, we take the ratio of the leading coefficients. So leading coefficient of the top over leading coefficient of the bottom. So leading coefficient here is a 1 and a 1, so 1 over 1. So our horizontal asymptote is at y equals 1, okay? And then our y-intercept is where we plug in 0 for x, okay? So we go y equals 0 over 0 minus 3. So 0 over negative 3 is just 0. So our y-intercept, we put 0 for x, and we got 0 for y. So 0, 0. Okay? So we worked on finding all of that stuff last time. Now let's put it on the graph. So let's see. Since I already got the black pen here, y-intercept would be at 0, 0. The horizontal asymptote is at y equals 1. So horizontal asymptote, y equals 1. Our vertical asymptote is at x equals 3. So vertical through x equals 3. And then our 0 is at x equals 0. So this same point right here, okay? So what we got to do here is remember, now that we have a point over here in this bottom left area, right? So this bottom left area, there is a point down here, right? So that means that there's a branch down there. So what we're going to do is we're going to draw in that branch, right? So we're going to be in this little area, drawing this branch, okay? And then remember, our branches are going to be diagonal unless there's a double root. None of these are double roots, okay? So our branches are going to be diagonal from each other, so we don't need the wave. Okay, branches are diagonal from each other. Right, because there's no double roots. Okay, so since this one's in that bottom left quadrant, that means that our other one's going to be up here in this top right. It's going to be diagonal. Okay, so that's what we got. All right. Now for the next guy, okay, again, zeros come from the top. So x minus 5 equals 0. So add your 5 over. So we get x equals 5. Vertical asymptotes come from the bottom. So x equals 0, right? Horizontal asymptote, again, we check the degree. So both of those are x equal, or x to the first. So degree of the top is the same as the degree of the bottom. So we go leading coefficient of the top, leading coefficient of the bottom. Those are, again, 1 over 1, right? So it's at y equals 1. And then for our y-intercept, plug in 0 for x. So we go y equals 0 minus 5 over 0. Negative 5 over 0 is undefined. So since it's undefined, that means this thing has no y-intercept. Okay? So as we go through here, right, let's put, there's no y-intercept put on there, so let's go with zeros. So zeros, we got 1. It's going to cross the x-axis at 5. Vertical asymptote, we've got x equals 0. Horizontal asymptote, we've got y equals 1. Okay? And then, again, since we have a point down here in this little quadrant, that means that a branch is going to be in that quadrant. So as we draw this on here, we got a branch down here, and then there are no double roots. So that means our branches are diagonal from each other. So that means the other one should be up here. Okay? So that's what we're working with those. All right? Now, when we get into ones, like these on the back here, okay? So same deal. So if we want to find, again, the zeros, we go 2 times x minus 3 equals 0. So let's divide out that 2. And then we can add 3. So we get x equals 3 for that 0. Vertical asymptote from the bottom. Okay. Horizontal asymptote, again, we check the degree. So that is x to the first power. X to the first power, so the top is equal to the bottom. So leading coefficient of the top is a 2. Leading coefficient of the bottom is a 1. So horizontal asymptote's at y equals 2. Okay? And then our y-intercept, again, we plug in 0 for x. So it would be 2 times negative 3 over negative 4, which would be negative 6 over negative 4. And if we reduce that, that gives us positive 3 over 2. So 0 comma 3 over 2 for our y-intercept, right? So let's put all this on the graph. So y-intercept, 0, 3 over 2. So that's 0 comma 1.5. So right in here. And then our horizontal asymptote at 2. Y equals equals 2. Vertical asymptote at x equals 4. And then we have a 0 at 3. So right there. So now again, if we look, we have some points. We've got 2 points this time down in this quadrant, right? So that means that there's going to be a branch in that quadrant. So let's draw that in. So we've got, oops, change back to this pin. If we draw this in, right, we're going to go through here, back to this 0, and then down this way. Okay, and then for our second one, right, there are no double roots. So our branches are diagonal. Again. So that means this one should be top right, like that. Okay? So that's what we're working with. Now, last one. This is one where we got to factor. Okay? So in this case, if we want to factor the top 3 terms, so we'd be multiplying to -6 and adding to 1 would be 3 and a -2. Right? And then the bottom, multiply to 4, add to 4, be 2 and 2. Right? So now as we go to work with this, our zeros again come from the top. So we're going to have 2 of them this time. So we get -3 and +2 as our 2 zeros. Okay. Vertical asymptotes. If we look, we've got x plus 2 down here. So that's going to give us -2, but there's 2 of them. So that makes this thing a double root. Okay, so since it's a double root, that's going to change our branches. They're not going to be diagonal anymore. All right. Now, let's see. Then we go horizontal asymptote. So we look, and if we look, degree of the top is 2, degree of the bottom is 2. So ratio of the leading coefficients, we go 1 over 1. Okay, y-intercept, if we plug in 0, that'd be 0 squared plus 0 minus 6 over 0 squared plus 4 times 0 plus 4. So that would give us -6 over +4, which is -3 over 2. So our y-intercept would be -0, -3 over 2, right? And then we're going to put this on the graph and see if we need the wave based on what points we have. So 0, -3/2. So 0, -1.5. Be in there. Horizontal asymptote. We get there at 1. Vertical asymptote at -2. And then we have zeros at -3 and +2. So -3 and +2. Okay? So this is what we're working with. So now we've got points in this quadrant, and we also have a point in this quadrant. So we know where our 2 branches need to go. Okay? But I'm going to show you how to use the wave with this, just so you have it, because we're not always gonna have this. All right. So to do the wave, okay, we use the critical points, which are your zeros and your vertical asymptotes. Okay. So zeros, vertical asymptotes. We got a 0 at -3. And then we've got a vertical asymptote at -2, and then a 0 at 2, okay? So if we look, leading coefficient of this thing is positive, so that means the right side is up. And then we do have a double root at -2, so we're going to bounce at -2. Okay, so coming through, we're going to hit -2, we're going to bounce off, and then go back through, okay? So, again, remember, this thing, this is the x-axis. So, as we draw on our stuff, if we again think about it in sections, so we've got, let's see, this section right here, to the left of -3 is above the x-axis, so it's positive. So that means over here, when we're to the left of -3, we should be above the x-axis, okay? If we look at between these two, we should be negative, right? Here we were positive, here we're negative. So we're between -3 and 1. So between that 0 and that vertical asymptote, we should be below the x-axis, down there. And then between these two, between -2 and +2, we're negative, right? So between the vertical asymptote and this 0, we're negative, below the x-axis. And then once we get to, let's see, once we get to the right of +2, we're back positive. So we go above the x-axis again, right? So again, this part down here represents this part. The pink part is just this chunk between there. The green part is this area, and then that purple part is that part, okay? So that's how we're going to do the wave. Now, like I said before, we didn't necessarily need it on this one because we already had points in 2 areas, so we knew where the branches needed to go. But if we only have points in 1 area, we're going to have to do the wave, all right? So that's what we're working with. Try out that homework, and then let us know if you have any questions.